Thank you for watching this video. Now in today's part of the chapter, we'll be looking at trigonometry for Sec 2 types of questions. Revision for trigonometry. Now let's take a look at the first question. First question is saying that EADB is a straight line and AD is equals to 10 cm, DB is equals to 5 cm, BC is 8 cm, and AC is 17 cm. Explain why angle DBC is a right angle. Now, when the question requires us to explain why angle is a right angle, we are going to think of the Pythagoras theorem and we're going to use the converse of the Pythagoras theorem. But which angle are we going to look at now? This one is angle DBC. Okay, this is angle DBC. DBC is over here. They want us to show that this is a right angle triangle. But you notice that inside this diagram here, I only have the measurement 5 and the measurement 8. I do not have the measurement for the hypotenuse. So I will not use this triangle to help me to prove my right angle. Instead, I should use a triangle that has more information, and that will be triangle ABC. Okay, because the angle will also angle ABC is the same as the angle DBC. So if I want to show that this is a 90-degree angle, I need to check whether does the length satisfy the converse of Pythagoras theorem. So inside here we have this tree length over here. The longer side is 17, then the other two shorter side is 15 and 8. So inside my question, I'll write down the answer for, I'll start with the longer side first. So the longer side will be AC squared is equals to 17 squared, which is equals to 289. Then I need to look at my two shorter side, the other part of the equation. AB squared, not AD, because D is not a right angle triangle. Then BC squared. So it's 10 plus 5, 15 square plus 8 square. And that will give me 289 as well. Since this two has the same value, so since AC square equals to AB square plus BC square by the converse of Pythagoras theorem, okay, triangle ABC is a right triangle. But I have not answered to my question yet. They want me to show that angle DBC is the right angle. So inside this triangle ABC, angle ABC will be the one that has a 90 degrees. So angle ABC will be equals to the angle DBC. It will be 90 degrees shown. Okay, have you gotten the answer? Next part, expressing each answer as a fraction in the simplest form. Write down the value of tangent BCD. So tangent BCD, BCD is this angle over here. Tangent ratio, we have our chua, ka, and so the tangent ratio is opposite over adjacent. Okay, so tangent is opposite over it. Let's label the sides. So this is my angle here, DBC. So the opposite, the side opposite to this that doesn't touch this will be the side 5. Opposite. Then this side over here will be my hypotenuse and this must be my adjacent. So TOA, 5 over 8, opposite over adjacent, 5 over 8. And they want it in simplest form as a fraction. I'm not looking for the angle, so no need to write inverse. So the answer will be simply 5 over 8. Okay. Next question, find the sine of angle DBC. BDC, sorry. Angle BDC. Now I'm changing the side to this, the angle to this angle, BDC. Sines, then I must use the sine ratio SOH, opposite over hypotenuse. So I'm going to label now. This side now will be the opposite. Remember, angle changes, the side will change. The labeling of the sides will change with respect to the angle. So this will be opposite, this will be adjacent, this will be hypotenuse. But question, I do not know what is the hypotenuse. I got 5, I got 8, I need to find the hypotenuse. So this is the longer side. We'll need to use square root, a square, one side square plus the other side square, add together, addition. So let me find my hypotenuse first. Hypotenuse is DC. DC will be equals to square root 5 square plus 8 square. They want the exact value. So if the number is not exact, we should leave it in terms of a square root form. 5 square plus 8 square is 89. So this will be square root of 89. Okay, I'm going to leave it as a fraction, the exact value. So I'm going to leave it like that. Okay, then sine of the angle is opposite over hypotenuse. So it's 8 over square root of 89. So 8 over square root 89. Okay. Now, one more question for students who are in the Sec 3 level. You will also learn about obtuse angle. Alright, so this is cosine of angle CAE. Cosine of angle CAE is this angle over here. This is an obtuse angle. Alright, for students in Sec 2, you don't need to do this question. For students in Sec 3, please try this question. So, cosine of an obtuse angle. So, let's recall a little bit on some of the property for obtuse angle. For acute and for obtuse, sine is positive for both acute and obtuse angle. But the cosine will be positive for acute angle but negative for the obtuse angle. So angle CAE, the obtuse angle, I can't choose this angle because there's no right angle triangle here. So I need to use the angle on the other side, the acute angle over here. So in this case, I'm going to look at my whole triangle. Then this side over here will be the opposite. This one over here will be my adjacent. And this is my hypotenuse. So cosine is cosine ratio CAH, adjacent, which is the number 15, over the hypotenuse, which is the number 17. So this one will be 15 over 17. Check whether can you simplify. Cannot be simplified. So this one will be the answer. Okay, have you gotten the concept? If you are ready, let's move to the next question. Question number 2. Now, question number 2 over here inside this diagram, XQY is a straight line, so it's a straight line over here, and angle XYZ is XYZ is 90 degrees, okay. XZ is given to be 17 cm and XQ is 9 cm. The area of the triangle is 36. So for this kind of question, we are going to use area of triangles half times base times perpendicular height. Okay, so if I want to find YZ is the side over here. Okay, if this is going to be my perpendicular height for the triangle, then where will be the base? The base will be the side 9 cm. Okay, so I'm going to use the area of triangle. Area of triangle is half times base times height. I'm going to replace it with numbers, so it's 36. Half times my base will be the number 9, and the perpendicular height will be the YZ that I want to find. Okay, so I'll find YZ. I don't want a half, so we divide by half. We divide by the number 9. And I get my answer YZ to be the value 8. Okay, so this one will be the number 8. Next one, we have to find the angle ZXQ. Where is angle ZXQ? ZXQ is over here. Now, if I were to look at ZXQ itself, I don't have enough information because it's not right angle triangle in Sec 2 syllabus. I want to use the Trigonometry, so I need to find a right angle triangle for me to use. So in this case, I'll try to use the right angle triangle over here. Okay, XZ Y. So I should use the triangle XZY. I just draw this out again. So this is my 90 degrees. I found this one to be 8. And this one to be 17. I want to find this angle. But I do not know the YX, so it doesn't matter. I'm going to use my Trigonometry. Let's take a look at our Trigonometry. Tangent ratio, cosine ratio, sine ratio. This is my angle. This will be the opposite. This will be my hypotenuse. So which ratio have O and over H? So O over H will be the sine ratio. So in this case, sine of the angle ZXQ is equals to opposite, which is 8, over the hypotenuse, which is 17. Now, in order to find length, we need to use inverse, right? So we're going to do inverse ZXQ to be sine inverse 8 over 17. Right? Make sure your calculator is of the correct mode. Shift sine 8 over 17. Now, working phi SF, final answer for angle will be in 1 decimal place. So 28.1 degrees, 1 dp. Okay. Next question. Find the shortest distance from point Q to the line XZ. Okay, what can we use? We can use the area of the triangle. There are two methods over here. I can use area of triangle or I can use the Trigonometry method. Why? Because I found this angle to be 28.072 degrees. Right? So I'm going to do the first method first. Method number 1. I'm going to use the area of triangle. Area of triangle they gave me is 36. So area of triangle is 36. Half times our new base will now be this one with this perpendicular height, the shortest distance. So my new base will be 17. The shortest distance, the height here, I'll let H be shortest distance. Right? So dividing across, I'm going to divide away half, divide away 17. And I get my answer to be 72 over 17 in decimal places. H to be 4.2353. Then I round off 4.24 cm according to the units. That's method 1. Okay, now I should do method number 2. I'm going to use the Trigonometry. Method 2. Right, I already know inside this small triangle over here, this distance that I want to find, which is the H. And this angle is 28.072 from our previous working. And I know QX is 9. Okay, so if I were to label this one, this is my angle, this will be my opposite, this will be my hypotenuse. So, Twa, Ka, and so we'll use the sine ratio because got O and H. So, sine of the angle opposite, which is my H, the shortest distance that I want to find, over my hypotenuse, which is 9. I'm looking for a side, only a length, so I just need to cross multiply. No need to inverse, okay? So I cross multiply. So h will be equals to 9 times sine 28.072. And I get my answer 4.2352. Then we round it off 4.24 cm. Same answer. Okay, have you gotten the concept? Question number 3. The diagram 1 shows a path AC in the park ABCD. It's given that AC is 580 meters, BC is 370 meters, and AC is perpendicular to BC. So we have a 90 degrees over here. Question asked me to find the angle ABC. So this is my angle ABC. Then I need to use the trigo ratio, tangent ratio, cosine ratio, sine ratio. Okay, so let's take a look. Angle ABC. Over here, I have, this is my angle, so this side will be the opposite because it does not touch the angle at all. This is definitely my hypotenuse and this is my adjacent. So which are the sides that we have numbers? The A and the O. So A and O, what will we use? A and O will use the tangent ratio. So tangent of angle ABC is equals to opposite over adjacent. So opposite is 580 over my adjacent 370. Okay, in order to find angle, we use the inverse. So angle ABC is tangent inverse 580 over 370. I get my answer to be 57.465. Rounding off to 1 decimal places, 57.5 degrees. Have you gotten the answer? Next one, I need to find the length of AB. Well, inside my triangle, I already have 370 and 580. So in order to find the hypotenuse, I'm going to use the Pythagoras theorem. So AB will be equals to, I'm finding the longer side, I need to add the two of them together. So it'll be equals to square root of 370 square plus 580 square. And I get a value of 687.97, rounding it off, 688 cm, oh meter, sorry, 3 SF. Okay, now I'm going to move on to part 2, the last part of this question. Diagram 2 shows two other paths, AE and CE inside the park. It's given that CAE is the angle 25 degrees, so we got this to be 25. And we know for this side we have the hypotenuse over here. This is my 90 degrees, right? So this is my hypotenuse. Then we have the other angles. This one over here is 70. Right, and I have the angle 90 degrees. Find the angle find the length AE, sorry. So let me just draw this triangle out a little bit. This is 580 and it's my hypotenuse. This is the angle 25, A to E. Okay, let's label this. So I have my angle is 25. This side will be my opposite. And this side will be my adjacent. Then this one is my hypotenuse. Okay, so they want us to find AE, which is the adjacent. Let's look at our trigo ratio. Tangent ratio, cosine ratio, sine ratio. So I have A. I want to find A, the adjacent, AE, and the hypotenuse, A and H. So that will give me the cosine ratio. So cosine of the angle 25 degree is adjacent, which is AE, over my hypotenuse 580. So what we're going to do, we're going to find so we're going to find the length. So now we are going to do cross multiplication, no inverse. So we cross multiply, right? I will get AE to be equals to 580 times cosine 25 degrees. Okay, then I get my answer 525.65 or 66, rounded off 526 meters, 3SF. Okay, last but not least, they ask us to find the area of the whole ABCD. Well, this can be split into two parts. I have two triangles. The first triangle ABC, this is 370, this is 580. I can use half times base times height, right? Then next one, I need to look at the triangle over here. This triangle, this is the 70 degrees. This is A, C is 580, and D, that's all. So if I want to find the area of this triangle, I'll probably need to find the length AD, right? So I'm going to use my Torcaso again, Trigo ratio again. So this is my angle 70, right? This will be my opposite, which I need to find. And this one will be the adjacent, right? So out of my Trigo ratio, I have O, I need to find O, the opposite, and the A, the adjacent. So I should use the tangent ratio. So tangent of 70 degrees, TOA will be AD over 580. We are looking for length, so we should just cross multiply. So AD will be equals to 580 times tangent 70. And that gives me 1593.6, okay, meters. But since this is only the working, not the final answer, I'll leave it in 3 sig fig. So now I want to find the area. I should find the area of each triangle. So area of ABCD is made out area of two triangles. The first one, half times base times height. So 580 times 370. Oops, why is it in red color? Plus the area of the second triangle, half times base 580, and I found my height just now, 1593.6, right? So times 580 times 1593.6, and that will give me 580, 370 plus I get a total of 569,444. Okay, in this case, this one is not an actual answer because this number over here is already in 3 sig figure. So what we have, we'll round this off to 3 sig fig, 569,000 meters square. Have you gotten your answer? Okay, with that, we have come to the end of this part of the lesson.